So hello everybody. Today I want to cover a bunch of like basic Algebra 1 standards. So I'm going to make this first video is on exponents. Okay, a bunch of little exponent formulas. So we're going to start with the basic idea of what does an exponent even mean. We're going to go all the way back to the beginning. Okay, so what's 2 squared mean? All right, one of the most common things that people will do is think that something to the second power means you just double it, all right? I don't know, maybe that comes from the fact that 2 times 2 is 4, all right? So then people will be like, oh, you just doubled it, right? And so they'll think that 3 squared means 6, okay? It's not 6, okay? What it really means, squared, let me make that look like a dot. Yeah, 2 times 2 equals 4, okay? What this square means is how many times do you repeat multiplication of this number, all right? Well, you're going to repeat multiplication of 3 twice. So we do 3 times 3, all right? And what's that? It's 9, all right? So that's pretty much the way you're going to be expressing these things. They could get a little more complicated, right? Maybe you have 2x. What's 2x cubed? Well, it's telling me how many times am I going to multiply 2x? I'm going to multiply it 3 times itself. So 2x times 2x times 2x. And if we look at that, that's 2 times 2 times 2 times x times x times x, all right? And so the way that we abbreviate, well, 2 times 2 is 4, and 4 times 2 is 8. So we could shorten it by just writing 8. And then x times x times x, a shorter way to write that is just x cubed, okay? So 2x to the 3rd power equals 2x times 2x times 2x. And once you rearrange all the terms and kind of combine like terms with each other, you get 8x cubed, okay? So just make sure that you remember what is going on here, okay? You're repeating multiplication that many times. So here we go, all right? Let's try to do 3 to the 4th times 3 to the 2nd, all right? Well, we just learned that this means repeat multiplication 4 times, all right? And then what do? Then you multiply it by repeating multiplication 2 times, all right? Well, I can combine these. I see that I'm really doing 1, 2, 3, 4, 5, 6. So that means the same thing as repeating multiplication of 3 6 times, okay? So that's 3 to the 6th power, all right? Well, we're going to learn 2 easy formulas, okay? The first formula is probably the main one you should remember, okay? If you have x to the y power and you're multiplying the same number as the base, okay? So let's talk about these numbers real quick, okay? If I have any number and any exponent, okay? This number right here, we call that the base. Just so you guys know what I'm talking about when I say this. And this right here is called the exponent. Okay, just to get all the way down to the basics, okay? So this is the exponent, and that's the base, okay? So we could say 3 to the power of 2, okay? You could say it a lot of different ways, 3 to the 2nd power. But we always know that 3 is the base, and the exponent is 2, okay? So if you look at this expression that I have right here, our bases are both x. So our bases are the same. So when your bases are the same, all you really have to do is do y plus z, all right, to use that formula. And why does that formula even work? Well, let's think about it. Well, what does x to the y mean? It means x times dot 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 times x. How many times does this happen? It happens y times, because that's x to the y power, okay? And these are supposed to be ellipses, which mean dot, dot, dot. So I'm trying to show you the pattern continues indefinitely, all right? If y is 7, then I mean to say 7 x's, all right? But now for z. So this is going to be x times dot, 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 x. And how many x's would there be in this case? There would be z times, all right? Well, what is really going on? How many times am I multiplying x, okay? all right? If I do it y times, and then I do it z times, how many times am I doing it all together? Okay, I messed that one up. You guys are going to laugh at me for that one. Alright, well, I did it y times and then I did it z times. So we combined them, and all we're doing is counting. So if we did it y times and z times, then what we have left over is y plus z times, okay? That's how many times we multiplied x. So that's why we're just going to use this formula, right? X to the y plus z when you have common bases. When the bases are the same, you can just add the exponents to simplify it. Let's try it, okay? So we're going to keep this formula up here so that you can figure out what's going on. Okay, so let's do 1, 2, and 3 different problems, all right? So we'll do 3 to the second times 3 to the 5, all right? I'll fix that 5. And then we're going to do x to the 7th times x to the 3. And the last one we'll do will be 3 to the 2nd times 4 to the 2. Alright, so in this case, do we have common bases? Yeah, we do. And so we know we can use our formula right here. I'm going to put in this box, okay? Is x to the y plus z, okay? So that doesn't look like a plus. Sorry, the starboard's a little on the fritz. So, there we go. X to the y plus z. So this is going to be 3 to the 2 plus 5. And what's that? 3 to the 7. This is going to be x to the 7 plus 3. And that's going to make x to the 10. And we could do that in here because are they the same base? Yeah, the bases are equal. So you can add the exponents. Now here, can we say this is 3 to the 4th? Can we say it's 4 to the 4th? No. We cannot combine them because you can only add exponents if the bases are equal, okay? Are these bases the same? They're not the same, all right? This base is 3 and this base is 4. So in that case, you actually cannot combine them, okay? You don't add the exponents like that. In that case, to simplify it, you would just have to multiply it out. So 3 squared is 9, 3 times 3. 4 squared is 16, 4 times 4, right? And that's 90 plus 54, so we get 144. All right. So it's not every case that you see two things multiplying that you just run and add them. Okay. Only in very special cases, and we're really happy about those cases when these are equal. All right. When those bases are common, when it's the same number, we're happy because we know all we have to do is add them up. All right. So good job with that formula. Let's learn the next formula. All right. The next formula is let me fix that. I got it's a little oblong. So we're going to have x to the y power and then raised to the z power. So it's kind of like double powers, okay? So what does this really mean? To make a long story short, okay, it means x to the y times z. And now why does it mean that? Okay, why is it going to be y times z? Well, because this means that I have to copy y z times, right? So think about what this means. X to the y to the z means that you have x to the y times x to the y times x to the y however many times. How many times do I have to have this? I have to have it z times, right? Well, if I have y z times and I have to add up y z times, then I get z times y, or y times z, however you want to look at it, okay? So really, you just have to multiply the exponents when you see the exponent outside of parentheses. Multiply them, and then you can combine it like that, nice and easy. So let's apply this formula, guys. Our first problem will be, alright, let's do 3 squared to the 7th, alright? So like I said, when you see an exponent outside of the parentheses, that means you multiply them. So we get 2 times 7, and that equals 14. So we got 3 to the 14th. All right, let's try another one. Let's try 2x squared to the 7th. Alright, what's that make? Well, we're going to get 2 to the 7th, but then x is going to go to what power? The 14, alright? So this is like treating it times 2 to the 1. We just multiplied the 7 times 1, and that's 7, alright? So there you go for this one. Let's try this one over here. Let's go something more simple. Let's do 5 squared to the 10. So what's that make us? It means 5 to the 2 times 10. And what's that make? 5 to the 20. Okay, so hopefully you guys can remember what's going on. You have to multiply exponents, okay, if they're outside of the parentheses. You multiply them together, and then you have your answer, all right? Let's try one more of these. Scroll down a little bit. All right, so let's do 4, 5, and 6. Okay, so let's do x squared cubed. What's that? All right, whatever you do, don't add them, okay? Make sure that you remember, hey, it's outside of the parentheses. It's almost like distributive property or something. Just multiply, okay? Remember, parentheses usually means multiply anyway, so right now, just go ahead and multiply. So 2 times 3 makes 6. Okay, so you got that. Let's try x to the 4 to the 11th power. Well, that means x to the 4 times 11, and that's 44. So we got x to the 44. Let's do one more. Let's do 3 squared to the 8th. All right, and that makes 3 to the 2 times 8, and that gives us 3/16. All right. If you have a negative number in here, you can go ahead and multiply it. We'll talk about negative exponents right now. Actually, we're going to do that for the next formula, so we'll start dealing with negative exponents right away. All right, get ready. Here we go. So one of the main formulas that you have to remember for negative exponents is this one. The most important one, okay? If you have any number to any negative exponent, it's just 1 over that number, but to the positive power. So let's write a bunch of them, okay? Let's do x to the negative 2. Well, that's 1 over x to the positive 2. What's x to the negative 3? That's 1 over x to the positive 3. All right, what's x to the negative 4? That's 1 over x to the positive 4. Okay, I hope you guys get the idea. So let's see a couple other examples of real numbers, okay? 1 over x to the y, okay? So all you do is move it to the bottom of 1 and make it positive, okay? And that's gonna solve your problem. So let's do 3 to the negative 2. Well, that makes 1 over 3 to the positive 2. And what's 3 to the positive 2? That's 3 squared. That means 3 times 3. That's 1/9, okay? So it doesn't make a negative number just because that exponent's negative. It actually makes a fraction. It's going to make a fraction every time, okay? So let's try 4 to the negative 2, all right? Fix that too. 4 to the negative 2 equals 1 over 4 to what power? 4 to the positive 2, okay? I hope you see the connection. This negative becomes positive after you put it underneath 1. Now we just do 1 over 4 squared, and 4 squared is 16. Okay, so there you go. You have some help for these problems. We're going to have to learn a new quotient rule right now so that we can start finally using this in a more complicated form. Okay, so I'm going to give you guys one more. All right, try this one by yourself. All right, x to the negative 7. All right, how do you write that? I hope you got 1 over x to the 7. All right, that's what we're going to do. So let's just start up this problem with the last formula that I have for you, okay? Is that if you have common bases, all right, so x to the y and x to the z, then really what we're doing is we're going to be subtracting, okay? And why does that mean that? What's going on here, all right? Let's say that we have x times x, and how many times will we have that? Let's say we have it y times, because that's on top. So we have y x's, whatever y. Say y is 10, then we have 10 x's. If y is 20, then we have 20 x's, all right? This dot, dot, dot is just kind of standing for it to be as long or as big as we would need it to be, all right? It stands for y of them. And now let's say that we had z of them on bottom, all right? So x times x, all right? Well, if this was z times, how many things are going to cancel out? Well, we're going to end up dividing by the ones on bottom. So these ones on bottom are going to cancel this out, right? So we're going to cancel out exactly this many of them, right? So let's see. Let's say I had 5 x's on top, right? And let's say I had 3 on bottom. Then now I'm going to have 5 minus how many? 1, 2, 3. All right, so we would have x squared. So I hope you see how if I canceled off z of them, then we would be left with y minus z. All right, because the ones on bottom are going to help us cancel. So after I cancel z of them, we're only going to be left with y minus z after I take away z of them. All right. So let's use this rule to help us do some different problems. Okay, x to the y over x to the z equals x to the y minus z. And don't forget that we're subtracting the exponent that's in the denominator. Okay, subtract the exponent in the denominator. So let's go ahead and do 3 to the 10th over 3 to the 4th. What's that make? This will be our number 1. Well, this has to be 3 to the 10 minus 4. So what do I get? 3 to the 6th. All right, let's do another one, 2. Let's do x to the 8 over x to the 2. Well, that's x to the 8. And like I said, don't forget, you subtract the number that's on bottom. Z's on bottom, that's the one we're subtracting. What's 8 minus 2? That's 6, okay? So we get x to the 6 in this one. So now, I would like to introduce a couple more advanced problems than this, okay? You guys can, let's actually do a couple more of these, and then we'll do the hardest ones I could do. All right? I want to get to the more advanced ones, but here we go. So let's do 3 to the 6th over 3 to the 5th, all right? So this would have to be 3 to the 6 minus how much? 5. And 6 minus 5 is 1, so that's 3 to the 1, and that's just 3. So one more, all right? Let's do 10 to the 15 over 10 to the 12. All right, well, this makes 10 to the 15 minus the number on bottom, and that's 12. What's 15 minus 12? That's 3. So 10 to the 3rd equals 10 times 10 times 10, and that makes 1,000. All right, so there's a couple ways to look at the answer. Right? You can leave it as 10 cubed if you want, or put it onto 1,000. So here we go. The hardest problems I can think of are ones like these, okay, where you have to know multiple rules, okay? So what if I have x to the negative 4 times x to the negative 3? Well, the way I'm going to tell you to write this, okay, is basically, if it's negative, it cannot stay on the side of the fraction where it is. If it's on bottom, it's going to move on top. If it's on top, it's going to move on bottom. The only thing that's going to change is that the sign, after you move it, is going to become positive. The sign is going to become positive. So this is my favorite diagram to show it. It looks like a yin-yang or something, and this is really all you have to remember, is move this thing up here and make it what? Positive. So I'm going to write x3 up here and make it positive. I'm going to write x4 down here, but I'm going to make the 4 positive. And now we can do our math, right? Let's do it. Well, we're going to subtract them, right? So this is x3 minus 4. And that's x to the negative 1. And what did we say x to the negative 1 is? That's 1 over x to the positive 1. And that's the same thing as 1 over x, right? So there's a way to do these problems. Okay, let's do a couple tough ones real quick, all right? So here we go. We got a to the negative 1, b to the negative 2, and c to the negative 3. We got d to the negative 2, e to the negative 3, and f to the negative 4. Okay, so what happens? This example will show a lot of people what's going on here, okay? Because like I told you, if they're negative, they have to move to the other side. So if the exponent's negative, you're going to move it to the top or the bottom. Wherever it's at, move it to the other side. So, are all of these negative? They all are. Are they all going to move to the bottom? Yes. Negatives move to the bottom and become positive. So on bottom, we're going to have A to the positive 1, B to the positive 2, C to the positive 3. And on top, we'll have D to the positive 2, E to the positive 3, and F to the positive 4. All right? So let's go ahead and do one more of these. Let's try x squared times y to the negative 3 times x to the negative 2. Okay, so what's that mean? Like I said, if they're negative, they move. If they're positive, if the exponent is positive, it's going to stay exactly where it is. It's not going to move anywhere. Now, if the exponent's negative, it has to move. So the only one that's going to stay where it is this x squared that's positive. Okay? And then let me fix that. So we got 1x squared that's positive, and we know that this is going to come to the top. So it's going to become positive, so on top I'm going to have times x to the positive 2. Now this one is negative. The exponent's negative, so it has to move to the bottom. So on bottom I get y cubed, right? So I got x to the 4th over y cubed, alright? So, good work, you guys, okay? Have fun working out some exponent problems. I hope this provided some good review for you guys. If you need help with exponents and you want to get more practice, I can definitely give you some. So let me know what you need, and I'll help you out with that. I hope you like this exponent review, guys. I hope it cleared up some stuff, okay? Like I say, usually have fun doing your homework, guys. See ya.